Welcome, everybody. Welcome, welcome, welcome. Boop. So, yeah. How's everybody doing today? Sorry I'm late. I had to put some bread on to rise. It took me a couple of minutes longer to make the batch than I had anticipated. But that's okay. You guys are very understanding. Unless you're not, in which case, I apologize. So, might as well get right into our lecture topic for today, since we're still somewhat behind. Although we did manage to close the gap a little bit with testing and exceptions. So let's talk about classes. Not this class, classes in the programming sense. We are now going to enter into the wild frontier of object-oriented programming. You guys can hear me, right? Yep, good, okay. Cool! So, classes. Let's return to our idea of raising exceptions. We can raise exceptions in our code if it enters a situation where the code is not intended to handle. So, for example, if we are looking for find first even in the list L and there is no even number in the list L, we raise a value error rather than returning false or something that's a less efficient solution when you really should be raising an exception. We've got all of these common types of exceptions: assertion, index not implemented, recursion, runtime type, value, and zero division errors. But what if none of these pre-existing errors fits your particular situation? What if your code might fail because of flying monkeys? You're going to need a flying monkey error, but of course, the Python prelude does not supply such an error. What do you do? Well, my friend, there are a couple of things that you can do. Number one, you could raise your own an exception with your own custom error message. This is a slightly don't worry about that. This is this is an okay solution to the problem. If you say exception my error message flying monkeys, then you can get an exception that prints back the error message that you specify. Now, the interesting thing about this is what you're actually doing is you're instantiating an object of the error class. Errors, exceptions, these are objects. Objects, everything is an object. Everything in Python is an object because it is object-oriented programming. So, this isn't necessarily the best solution, however, because we lack the ability to test for this particular type of error using the except clauses, because that's a useful thing to be able to do. All this does is it creates a general class of exception with a custom error message. Fine. So, there must be a better way. There is. You can, in fact, create your own errors by defining a new class that modifies the existing definition of the exception class so that you can add new stuff to it. In the case of creating your own custom error, all you have to do is rename exception. So, if you wish to define a new error class, you say class flying monkeys inherits from exception, and we're going to get into inheritance quite a lot, don't worry about it. We don't want to actually add anything to this class aside from the stuff that's already included by inheriting exception. What inheritance is, in general terms, is you're taking another class and you're saying, okay, I want everything in that class plus some other stuff. If you say pass here, then you're skipping the bit where you get to add your own custom stuff to the class. And don't worry, we're going to get into formal definitions. We're just trying to motivate classes right now. So, once we have created the Flying Monkeys class, which inherits from an exception, we can raise a Flying Monkeys directly. And you can see we now have Flying Monkeys as a specific error. Oh, uh-oh. Did I just lose my connection? I think I may have just lost my connection. Nope, okay. I got a notification that said I might have lost my internet connection, so I wanted to make sure I was still streaming. But it seems I'm okay. So anyway, Flying Monkeys is defined in main. That's what the main execution is defined as within the context of a Python program. But it's pretty cool because we can now do try raise Flying Monkeys, and now we can accept Flying Monkeys. Print. It worked. There you go. So you can see that the accept block is treating Flying Monkeys as if it were a native error type that was defined by Python itself, which is good. This is, this makes Python highly adaptable. Whoop, I hate it when I do that. Jeez. So yeah. Cool. So, let's talk about custom data types. Let's imagine that we have a family tree for well-known fantasy novel series family. My goodness, do those books have a lot of characters in them. It's like a frickin' Tolstoy novel. So, the other reason that you may wish to use classes is that classes are a way of enforcing data policies. So, you may not have realized this, but this whole time, you, the viewer, have been enforcing data policies as you have been programming. Anytime you've said, okay, this variable is going to be this, that variable is going to be that, that's enforcing a data policy. However, up to this point, many of the data policies that you, the viewer, will have been enforcing have been enforced at the level of your brain rather than at the level of the compiler itself. Wouldn't it be nice to be able to get the computer to check to make sure that the data is being used correctly? This becomes particularly useful and interesting when your when your program is going to be used by someone that's not you. Although you may have a good idea of what your data policy is this week, someone else probably doesn't, and you may not 30 years from now when you have to go back to your code. 30 years is an exaggeration. It only takes a couple of weeks to forget your data policies. So, let's examine this family tree type structure in terms of data policies. So, if we wanted to represent all of these people and the relationships between these people, we might do so in the following manner. We would have a dictionary that contains 3 fields: a name, a field for children, and a field for spouse. Name, obviously, that's the name of the person. Children points to a list of possibly other names, and then we have, other records, or, dictionaries. And then spouse is another one of these defined data structures. So, we might, fill in our lists in the manner that you might expect. we can assign to them afterwards, etc., etc. The convention was that every person should be represented by a dictionary with 3 entries in the dictionary, always the same names, the same keys, name, children, and spouse. However, we know that dictionaries are mutable data structures, and that people might get up to some shenanigans, adding fields to our dictionaries that we don't expect, and, and not including fields that we expect. So it would be nice if we could enforce that these particular fields must be existent and that they are the only things that can exist inside of this data structure. So, using conventions consistently is hard. This convention was that every person is represented by a dictionary with 3 entries in the dictionary, always the same keys, name, children, and spouse. What if one line of code, you misspell the tag, you misspell the key? Let's say you write to children instead of children. Well, what would actually happen is that the dictionary would add a new entry in itself for children, and that's where the data would be stored. So it would be stored in a spelling mistake, which is probably not what you want. What if you forgot a key in one person's dictionary? So you just forgot to enter the person's name for whatever reason. It can happen. People are people, and people make mistakes. Functions that expect certain keys to be present might fail. So if your function is reliant on the idea that name is defined and name ends up not being defined, you are likely to trip an index error or a key error. I think it's called a key error in a dictionary. So we can't use type or isinstance to distinguish between dictionaries that represent people and dictionaries for other purposes. So because we are if we're smushing everything into this very general purpose data type, it might be useful to tell it might be useful to use these functions to distinguish whether the dictionary is being used for this purpose or that purpose. I'm going to check for questions. No questions so far. Okie dokie. So, the idea is that we want to create a custom data type to represent a person that automatically has spots for the properties you want. We call these custom data types classes. Every class is built from an existing data type. That's a rule, even if it's like the object data type, or wait, is it called object? Inherits from, anyway, we're going to see it. We have to define a template for a custom data type. This has to tell us how our custom data type will be initialized and what operations you can perform with it. Then we can create instances of this class. The instance of a class is called an object, hence object-oriented programming. So, I will explain this another way. Classes are an abstraction mechanism, similar to functions. Functions are also an abstraction mechanism. What a function is it's a series of instructions that we all bundle together and package together and say, that's a function. What a class is it's a set of variables and a set of functions that have all been packaged up together into a single class. Yeah, so in the same way that you define a function, like at the top of your program, but it's not executed until something further down runs that function, in the same way, a class gets defined up at the top of your function, at the top of your program, but it doesn't physically exist until something creates an object of the class, or uses the class template to create an object, perhaps is a better way to say it. Questions? Nope? Okay. So, for example, going back to this family tree example, we may define a class called person. It inherits from object. Object is the most general thing that you can inherit from. It provides basically nothing except for a bunch of these system-defined things, as we're going to see. You can actually leave object out. If you just type class person with empty braces, it automatically assumes you want object to be inherited from. So, we define an initialization method. The initializer defines self.name, self.children, and self.spouse. Now, the whole self thing is something that normally confuses people, so we're gonna talk about it to some length today. So let's see, I think we're gonna cover it in well, maybe not. Okay, so let me open up a Python file and I'll see if I can show you guys some stuff that might make this a little more clear. Get it! Classes.py. So, let's make our custom class for person, right? We are defining an initialization method. It has to be called __init __. This defines it. This means, in technical terms, what we're doing is we are providing a definition for the initializer method that is provided by default when you inherit from object. So it takes one argument, which is self, and it defines self.name equals empty, self.children is equal to an empty list, and self.spouse is also an empty thing. So self refers to the object itself. It's only called self by convention. When you actually create an object of this class, let's say we create an object and we're going to call it Harry, and we create a person. So we can then say Harry dot name is equal to Harold. We can then use that in expressions in the same way you would expect to use anything. So let me execute this, and you shall see. Python 3 classes.py. See, it prints Harold. So what's going on here is this is known as dot syntax. You access the variables that are stored inside of a class by invoking the name of the class and then putting a dot and then the field that you want to access. So variables contained in a class are called fields, and functions contained in a class are called methods. So you might be saying, well, this is kind of facile. Why do we need to be so specific? And of course, the answer to that is you may have several objects named different things. So if we have like Frank is also a person. Frank.name is equal to George for no particular reason. If we execute that, you can see the first thing, the thing before the dot, specifies which object that's currently in memory is the one we're talking about. So it would be interesting to take this program over to Python Tutor. Python Tutor. See what Python Tutor has for us. No, we want Python, thank you. So, we've got global frame person. Person is has a method in it and a function that takes self. As we go through, we add the following fields to the init class, or to the person class. Going back to the global frame, we have Harry. Harry is an object of type person. It's a person instance. When we add Harry.name to Harold, you can see Harold goes into the name field, and then, you know, so what it's doing with the pointer here is when you hit this is initializing a new instance of the class. When a new instance of the class is initialized, it executes the code inside of the init, inside of the initializer method. And you can see it goes through each statement in there and initializes all of the, in this particular case, we are just declaring variables, but you know, you could run any type of code in there that you would like, including calling other methods inside the same class. So once we get back to global, you can see we have Harry and Frank are both now objects that they are instances of the person class, or objects of that class, which are in the global memory space. We can then assign things to them and work with them in order to do, you know, whatever we would like. Hopefully that makes things, let's see. When do you use classes and when do you use functions? So we're going to get to it a little bit, but whenever you have, like, a mental abstraction where you're like, well, you know, these functions really are only applied to this data, or data in this form, then in that case you want to take the data and the functions and package them together into a class. We're gonna get there and, like, sort of establish the mental framework for it. Can we only use self or other parameters? No, you can use other parameters for sure. So in this example, it would be appropriate to think of self as a placeholder for the people Frank and Harry. Yes, absolutely. Yes, 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 yes. It gets a little bit more clear when we start using functions other than method, or other than the initializer. So, okay. So, for example, let's say we wanted to define a new method inside the same class. So let's say let's do a method make old takes self. Self.name is equal to self.name plus the string, or no, actually, old, there you go, plus the string. So it just concatenates the word old onto the end of the string. So the way that you would invoke this new method, is also via dot syntax. I know I'm like doing a completely different thing from the slides, but this is important stuff to sort of get in your mind. So Harry dot make old will make Harry old. You can see that applies, that executes this code when you call the method. There's a different way of calling this method, though, that'll make it a little more clear what's going on with the self parameter. So this is, when you call a method like this, what you're doing is you're going into the object itself to look for the method to execute. But you can also just look for the method directly from the class template. So if you say person.makeOld, you can also access the makeOld method. However, it needs to know which object you want to apply the method to. So we apply it to Harry. If we execute that, you can see we have old Harold, which means that the old method was applied twice to the same object because both of these were applied. So when we are having the self parameter, this is what it means. So essentially, these are two different ways of writing the same function. You can either have the object that you want to apply the method to be the first element here before the dot, and then you call that method on this object, or you refer to the class definition, you then invoke the method, and then you specify the object that the method will be applied to. This is the form that makes more sense with respect to the manner in which the methods are defined syntactically inside of the class. But it doesn't mean that this is any more valid a way of doing it than this way. And to answer the other question, if you wanted to add some more parameters, you totally could. I'm just making 3 parameters to the initializer function. You got to call them something else, though. These are parameters in the proper sense, which means that you can add them and remove them as you please. Although, again, if you're asked for specific parameters in the context of an assignment, then it's probable that you should provide them. So in that case, we don't even have to have a specific assignment statement. We can just do it in there. You can see that's done the exact same thing. Make sense? Are there any questions? You described that way better than I did, lol. Well, you know, I am a professor. So, you know, describing things to people is kind of what I'm getting paid for. I'll take just a brief moment to let you guys ask any questions, because you guys may have questions related to classes. Oh. Okay. Sorry. Hilarious. You should have @Paul'd then. That's your fault, not mine. So can classes be considered as wrappers for functions? Yes. That would be... You can think of it that way. Yeah. However, you need to take that mental model of a class and expand it a little bit. It needs to be a wrapper for a set of functions. that can hold its own data. Can you put an if statement in a class? You absolutely can put an if statement inside of a function in a class. Inside of the functions of a class, you can actually do anything you want, right? Let's say we have n for I in range n that, right? You can use for loops, you can use if statements, you can use all of the tools which you have been developing in Python so far are accessible to you inside of a class, as long as you're doing it inside of a function. The space here does not function like the space out here. This is not code space. Everything that's inside of a class needs to be inside of a function inside of a class. But otherwise, yeah. So if we wanted to make if we wanted to make Harry old by 2 and then 5, then you will see that we get a syntax error because I forgot the frigging things. Gosh darn it. All right, there we go. So we can see we get old Harold. And that is 7 olds. So, which is 2 plus 5. So, math. But yeah. Cool. In this class person example, there are only 3 variables in it. Can we prevent other users from adding another variable to it? Well, yeah, because if you try to, like, if we wanted, like, Harry dot, hair color is equal to, pink. If we tried to do that, let's see what happens. I see it works. That's unfortunate. So, there's probably a way of doing that. Jeez. You can probably set protection levels somewhere. I'm not sure how to do it precisely, though. Yeah. That's a fair question. Let's see if we can find it. Ask the Googs. Python. Prevent. Field. Or I think they call them attributes. Stop. Prevent adding attributes. Yeah. Let's see what Stack Overflow says. Whenever I have a question I don't know the answer to, I ask Stack Overflow. You can add a function to explicitly freeze an instance. Okay. Yeah, okay. Ooh, there's a set attribute. Okay. So yeah, apparently this slots attribute, which is a default attribute. You can tell the default attributes because they've got the underscores before and after. So yeah, apparently if you use this, then you should be able to prevent people from doing other stuff. So let's try it. That business I said about not wanting to put anything in this space, that was like contingent on the idea that we hadn't quite gotten to the idea that you actually can initialize variables in this space. But, you know, in this course, we kind of do all of our variable initialization inside of init, so, you know. So let's see if this works. So here's a question. Can we see hair color? Does it actually fail? No, that doesn't work. What the heck, man? Did I miss something? I don't know. I don't know. I'm sorry. Sorry about that. Since everyone can change my class, what is the point of a class? Again, it's an abstraction mechanism. If we didn't take the parameters and then used a hairy person herald, would it work? Dynamic typing was a mistake. Thank you, Paul. Paul just expressed all of my true feelings about Python. Like, can we have public, private, protected members in a Python class? Yes, you absolutely can, Hansen. The way of doing that is by putting 2 underscores before the name. If you do that, then it's a protected class. That means that it's that means that the attribute can't be modified from outside of the class. To some degree, it's kind of useless to do this anyway, because all you're doing is like attaching data to an instance of the class that will never ever interact with any of the class's functions anyways, because, you know, the person who wrote the class never anticipated for a field called hair color. So obviously there wouldn't be any use of it inside of your maybe I'm inheriting it wrong. Let me see here. Since hair color wouldn't actually be used anywhere, you know, it wouldn't be, maybe I do have to inherit from object. Let's see. Object. Let's see if that... Ha! There you go. If you inherit from object, it works. So inheriting from object does do something. Ha! Okay, so yeah, slot works, but you have to inherit from object, because slot, I guess, is defined in object. So yeah, there you go. That prevents people from adding attributes to your class. So we found the answer. Cool. Yes. So, insert meme from last class. Yeah, really. We're gonna try to motivate classes. So, classes are first class objects, so to speak, in Python. So you can actually have like lists composed of classes, and classes can have other classes as fields, and, you know, anywhere you would have a regular variable, you can have a class. So it's pretty interesting. But yeah, so anyway, let's see how far behind or how much I've covered of these slides, because I haven't touched the slides in quite some time. So, to define a new class, use its syntax: class my class name, what it's built on, or what it inherits. We say that my class name extends what it's built on. So, person extends object, and flying monkeys extends exception. We can always extend the built-in starting point object and get slots while we're at it. So, next we have to define a template for our custom data type. We want to define how it's initialized and what operations you can perform on it. Init, with 2 underscores on either side, is a special function called the initializer. It is automatically called whenever we make a new instance of the class, as seen here. Inside the initializer, we can define instance variables that are associated with each instance of the class. We've got, in this case, name, children, and spouse. Instance variables are sometimes called members, properties, or attributes. And you will hear me call them fields. In other places, you call them fields. So I am from those other places, so I am often going to be referring to them as fields involuntarily. So, different instances of the same class can have independent instance variables. The correct way to think about it is as a separate object, in the same way that we, in the way that we did this in the Python tutor. These are completely separate things that do not interact with each other unless you tell them to interact with each other. We can also add functions to the class. So, for example, if we wish to have a Boolean test to see if the person is married, then we can return self.spouse does not equal none as the return value of this function. Obviously, that's a Boolean, so this is a function returning Boolean. If we try to execute it, if we have assigned Harry.spouse is equal to Ginny and Ginny.spouse is equal to Harry, Harry.married is going to come out true. These are called methods or member functions. So, and we did that with make old. We've got questions. Shouldn't it be object.name now? Not unless you call it object, but I wouldn't recommend that because that's a reserved system word. No, it's like this is the name of this instance, right? So when you want to access that instance, you have to use that instance name. Using the term object, like this doesn't really do anything except provide a bunch of stuff that you can't see in here. So, yeah. Yeah. So, yeah, so, this is actually a reasonably this is a few, this is, like, later down, but because we've made self.name a protected class by putting the underscores in front of it, if we tried to do that now, you would see, attribute error, person object has no attribute name, which is its way of, it won't admit to the existence of a protected field for security reasons. So what it will say is name doesn't exist. But name does exist, it's just protected. So if we wanted to access it, we would write, a new method. Nom, we'll go French. Self.name is equal to nom. Then we could use this Frank.change George. That would be a way of getting around that So oh, yeah, and I need to there. And you also can't access it to print it. So there you go. Somehow that seems to have broken the hair color thing. Anyway, so relative to other programming languages, the manner in which Python handles classes is extremely ugly and clunky and terrible, actually. In other programming languages, in order to make a variable into a private, a protected variable, all you'd have to do is say something like private spouse, or private string spouse. You would do something like that. You would tag it as being private at the front, but because Python is Python and Python is the worst, you actually have to put the double underscores in every single frigging place the variable name is used, which, relative to other programming languages, that is a terrible, terrible, terrible idea. It is a terrible way of going about it, but that's Python. You're learning Python. So anyway, Python is easy to learn. That's why it is for all of the people who want to learn programming. Anyway, let's see. Do we have any time to get into this? Not really. All right, so if anybody has any more questions, okay, so there's a question. Why would you make something private? What's the difference? So, the answer is security. So, if you have data that's inside of a class and you don't want people to be able to access or modify that data except through specific manners, except in specific ways, what you do is you protect it by controlling the access to the data. Like, for example, let's say we want to prevent people from changing the name of any person to Butts. So if nom is equal to Butts, then we print I see you, you dirty rat. Otherwise, we just comply. Right? If we then try to change Frank's name to Butts, it will, it'll not do that. If you were able to modify the name variable directly, then there's nothing you can do against someone who wanted to make the name Butts. So it's a mechanism for controlling access to the data. Generally speaking, there's a principle in programming that we haven't really talked about because Python is the worst. And also, this is a first-year class, but it's the principle of least privilege. So, generally speaking, when you're designing computer systems, designing software systems, the thing that you want is to give any particular piece of programming code or the user the least amount of privilege necessary for them to do the thing that they want to do. So you can imagine. If you have, for example, let's say you have a paint program, and that paint program, modifies image files. Does it need access to your kernel? No. Does it need access to your Wi-Fi password? No. Does it need access to the passwords that have been stored in your web browser if you choose to store your passwords in one of your, in the browser add-on? I always say no because I'm paranoid, but no, you want to restrict that program's access to the things that it needs to do it needs access to do its job. This is the same type of thing. You want to restrict access to the data, because if you don't restrict access to the data, it can make it much, much easier for somebody who's trying to get into your system and do nefarious things to do so. And people don't even have to be doing nefarious things. People do not even have to have darkness and evil in their heart in order to, seriously mess up your system by touching things they're not supposed to touch. Sometimes it can just be incompetence. So you want to keep incompetent people away from important things, as well as evil people. So there you go. I originally learned object-oriented programming through C#, which is much better. Now seeing it in Python, I'm just in disbelief. Yeah, Python is terrible. If we are using self.__name to make a variable private, then why are we using a slot? Because I'm trying to demonstrate multiple things on the same class. Don't worry about it. Probably I should change it in slot as well. There. Maybe that'll protect against the hair color thing. Nope. Okay. I don't know. Do you think Python is just an elaborate prank towards newbie programmers? Yes. This is the way... this is way different from how I learned it in Java, lol. Yes. Yeah, classes in Python are not, if you're used to classes in another programming language, this is yeah, anyway. Oh, is it slots? Maybe. Yeah, it's slots. Thank you. Sorry. Yeah, slots with an S, and then it works. Yeah. It's partially the fact that Python is so frigging dynamically typed that's causing all of this. But anyway, have a good weekend yourself. Thank you, everybody. I'll let you guys get to your next class. Take her easy, folks. Yep. Have fun. Not too much fun, but have fun.